So if you look here, for A, how are we going to express all this into a summation, okay, plus 81. Well, all this you know that is a square number, okay. So if you find it difficult for you, think of it as a sequence first. The sequence is called n square, because when this is u1 is 1 square, this is u2 is 2 square, this is u3 is 3 square, and this is u9 then is 9 square. So I know that the final r is equals to 9. Okay, so to translate this into a summation is called the summation of r equals to 1, okay, up till 9, because the last one is 9 square. Instead of writing n square over here, right, for summation we write it in terms of r. So this is called r square. Okay, so the first one is pretty straightforward, but the technique is think of it as a sequence, put the sequence over here in terms of r, determine your starting r and your ending r, and you will be fine. Okay, so for B, we are talking about 4 plus 8 plus 16 plus 32 plus 64 plus 128. Another way is very obvious. Over here, the number of terms is 6. Okay, the number of terms is equals to 6. So from 4, again, think of it as a sequence. From 4, how to get to 8? You can think of it as plus 4, right? Or you can think of it as times 2. So I look at this again. 8 to get to 16 is plus 8 or times 2. So which one is a better one to identify as a sequence? Of course, is times 2, times 2, times 2 over here. Okay? And then, so I know that this times 2 means it is a GP. A is equals to 4. R is equals to 2. And I already know that my number of terms is equals to 6. Okay, so if I put it in terms of a summation sign, the sequence is here, sequence. Think of it as a sequence. What is the sequence of GP? UN is equals to 4 bracket 2 to the power of n minus 1. Okay, now I put this into here, but in terms of R. 4, 2 to the power of r minus 1. My starting r is equals to 1, my ending r is equals to 6. And if you can actually simplify, because 4 is 2 to the power of 2, this would be the same as writing 2 to the power of 2 multiplied by 2 to the power of r minus 1. And your final answer is going to be from r equals to 1 to 6, 2 to the power of r plus 1. Okay, so it's not hard to put this into a summation form, and vice versa. If you have this, all you need to do is to sub r equals to 1 plus sub r equals to 2 plus sub r equals to 3, and so on and so forth. Okay, I'm going to work with the next one, which is C. If I have 3 minus 5 minus 13 minus 21 minus 29 minus 37, again the n is equals to 6. 3 to get to 5 minus 8. Think of the easiest way. This to this, it's still minus 8, right? So I know that this is going to be an AP. My A is equals to 3. My difference is equals to negative 8. So now I put it into the summation sign. R equals to 1 up to the 6th term. What is the sequence for AP? It is UN. Let's put it UN, because previous chapter we keep using UN, right? A plus D bracket n minus 1. So this is going to be 3 minus 8n plus 8. That will be 11 minus 8n. I just need to put it here, minus 8. But instead of writing n, I write r. And this is how we use the summation sign. Okay, this is how we transform it into a summation sign. Okay, I'm going to do something that is more difficult, which is E and F. E is talking about 1 times 2 plus 4 times 3 plus 7 times 4 plus 10 times 5. Okay, and the question says there are 20 terms. So we know that n equals to 20. Now, how to make a sequence for this is, think of it separately. 1, 4, 7, 10. Okay, I'm just going to write down 1, 4, 7, 10. Plus 3, plus 3, plus 3. I know that this is an AP. Okay, and what is the UN for this AP? Is 1 plus 3 bracket n minus 1. Make it nice, this will be 3n minus 3 plus 1, 3n minus 2. Now I look at this 2, 3, 4, 5. So this is U1. When it's U1 is 2. When it's U2 is 3. When it's U3 is 4. So for the green one, UN is equals to N plus 1. Because when it's 1 is 2, when it's 2 is 3, when it's 3 is 4, when it's 4 is 5, so on and so forth. So now I can put this into a summation sign. The summation of R equals to 1 up to 20th term. What is the formula? The one that is highlighted in yellow is the UR for the red one, which is 3R minus 2 multiplied by R plus 1 for the green one. And that's it. You can expand, you can don't expand. I think you can leave it as that. That is the purpose of this exercise. You are not going to get something like this in the exam form. Okay, so pay attention to F because F is pretty hard. I have x over 3 minus x squared over 5 plus x cubed over 7 minus x power 4 over 9. Okay, plus dot 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 to the n terms. So I know that my ending R is n. Okay, this is called an alternating sequence. If you are not sure about alternating sequence, please go back to 505. Okay, first video at the bottom I talk about alternating sequence when it's plus minus. Okay, or maybe at this point let me just quickly talk about it. Okay, if you have a sequence that is like minus 1, 1, minus 1, 1, minus 1, 1, this sequence is called negative 1 to the power of n because U1 is negative, U2 is positive, U3 is negative, U4 is positive. Okay, so when your power is even, the negative 1 will become 1. So that's why, can you see U2 and U4, all these are even power. So that's why when I have negative 1, 1, negative 1, 1, it is called negative 1 to the power of n. But if I have 1, negative 1, 1, negative 1, 1, negative 1, and so on, it is going to be called negative 1 to the power of n plus 1 because I want the first term to be a positive power. Okay, so U1, but negative 1 to the power of 1 is negative. But if I want it to be positive, I want to make it to become power 2. Okay, yeah, so that's why if you want to make it to be even, to be positive, I use negative 1 to the power of, okay, n plus 1 for if I start with the even sequence. Okay, so now we are talking about this. Let me write this again. X over 3 minus x squared over 5 plus x cubed over 7 minus x power 4 over 9, so on and so forth. Okay, I already identified that my first one is a positive, negative, positive, negative. So my sequence is going to have a negative 1 to the power of n plus 1 over here. Okay, the plus minus will translate to a negative 1 to the power of n plus 1. Okay, now we don't care about the negative anymore. X over 3, x squared over 5, x cubed over 7, and x power 4 over 9. Let's try and make a sequence for this. This guy, the x, the power increase, right? So it's just going to be x to the power of n. Because when I put at my first term, this is power 1. My second term, power 2. My third term, power 3. My fourth term, power 4. Okay? And my denominator, 3, 5, 7, 9. All these are odd number. Odd number have the general formula of 2n plus 1. Okay? Because 2n is an even number. Every even number, there's an odd number in front, 2n plus 1 or 2n minus 1. Why I don't use 2n minus 1? Because when this is u1, this is 3, right? 2n plus 1 works for 3. 2n plus 1 also works for 5. I will write down 2n or plus 1 as the denominator. So now I already fixed the sequence, right? Which means that my answer for this is summation of r equals to 1 to n. What is the sequence? Negative 1 to the power of r plus 1, not n plus 1. X to the power of r over 2r plus 1. Okay, yeah, and that is how I do this series with an alternating sequence. Okay, if you are not very sure about this, please go back, rewind this part and make sure you understand what I'm talking about.